All right, let's look at some other substrates. We've been really just focusing on alkyl halides, but let's look at some other substrates that can undergo substitution and elimination. One of these things that we're going to look at is our alcohols. Now, there's a little um, catch to using an alcohol. If I were to try to do, say, a substitution of an alcohol using Br minus. It's a great nucleophile. The problem I run into is that there would be no reaction with this. And think back to when we were talking about substitution. Why will there not be a reaction here? OH minus is not a good leaving group. So the solution is make it a good leaving group. If I could make this somehow water, I can make OH into OH2 or water, H2O, then that's a great leaving group. And one of the ways that I do this is instead of just using like sodium bromide, I'm going to use HBr. Or I could use HCl as well if I wanted to replace that OH with a chlorine. But here, we're going to substitute the OH for a bromine. Now, how does this suddenly happen? Well, the acid has something that sodium bromide did not, a proton to donate. So we're going to donate that proton to the OH, do a proton transfer, and look what happens now. Now I have a good leaving group. So since that leaving group is on a tertiary carbon, I'm going to have the leaving group leave. So this is going through an SN1 mechanism, and I get a tertiary carbocation. And now the bromide is going to come back in. And we've done our substitution. So when the problem that arises is that OH is a poor leaving group, we make it a good leaving group by doing it under acidic conditions. Now, one thing I want to highlight about this is that this process is not as useful for primary and secondary alcohols. There's a lot of rearrangements that happen in this case. So the way around that is instead of using HBr or HCl, use a different reagent known as thionyl chloride, or SOCl2. I would memorize this name and formula. So we do this reaction with thionyl chloride, SOCl2, and a base. This is known as pyridine. I would just memorize this name and structure. You're going to see pyridine come up a whole lot. And this will replace the OH with a chlorine. We'll talk a lot more about the mechanism and everything later in another chapter. But right now, I just want you to know that you could use this for primary and secondary alcohols. And if the alcohol started off on a chiral center, this does result in an inversion of configuration. Now, if I wanted to replace this with a bromine, I would use PBr3. And again, that results in an inversion of configuration. And like I said, I will touch on the mechanisms on this in another chapter when we go a lot more in depth into alcohols. We'll look at the mechanism later. Now, on the flip side of this, we talked about substitution of alcohols. Let's talk about dehydration of alcohols, which takes an alcohol and converts it to an alkene by removing water or An elimination reaction. So the way this is typically accomplished is by reacting it with concentrated acid, usually sulfuric acid, and sometimes a lot of heat. Sometimes you don't need a lot of heat, but usually there's some heat involved. And the thing that you need to remember, because that was something we talked about um, earlier in the semester, I can't remember exactly what unit it is, but we talked about the leveling effect with acids. So I think this is the acid base unit. The actual acid in this reaction is hydronium. And so the same thing happens here where we're going to protonate the alcohol. Now it's a good leaving group. What mechanism now do you think this is going to undergo? If we're going to make an alkene, if we're going to do an elimination, do you think this should be E1 or E2? Well, if you think about it, do we have a strong base? No, we're doing this in under actually acidic conditions. So this would be very, very, very weakly basic. So we're going to go through an E1 mechanism. So leaving group leaves to make a carbocation. And then we're going to use a weak base like water to pull off a beta hydrogen. And we get the Zystev product. Now let's look at another situation here. So this was a tertiary alcohol. What about a primary alcohol? Because a primary alcohol will do an elimination. But do you think this will go through an E1? Go back a couple pages in your notes. Can you do an E1 on a primary? No, because you have to form a carbocation. So what other possibility is there? Well, we can still do an elimination. We'll make that OH a good leaving group. And we're going to, in this case, do an E2 elimination. You say, wait a second, doesn't that require a strong base? Most of the time, yes. But this is going to be very, very slow because we have a weak base, which is why it requires a lot of heat.